So today, we're going to pull back the curtain on something that pretty much runs our entire digital world, big data. We're going to break down what it actually is, why it forced a revolution in how we store information, and how the solutions they came up with are now running in the palm of your hand. All right, so here's how we're going to tackle this. First, we'll look at the problem itself, this just massive explosion of data. Then we'll dive into how the big internet companies reacted, the amazing tools they built like Hadoop, and the whole new family of databases called NoSQL that came out of it. And finally, we'll bring it all home and see how it all connects to the apps we use every single day. So let's kick things off with the big problem, right? The data deluge. What actually happens when the sheer amount of information you're trying to handle just completely breaks the systems you built for a totally different era? This whole breakdown of the old way of doing things, it forced a new term into our vocabulary, one you've probably heard a million times. But what actually is big data? You know, it's really not about just having huge files. It's way more accurate to think of big data as a movement, really. It was a response to a new set of challenges that pushed the traditional database systems way past their breaking point. And the core of those challenges are famously known as the 3 V's. First up, you've got volume. And I mean, the scale here is it's almost impossible to wrap your head around. Think of it like this. A company like Facebook has to process hundreds of petabytes of new data. That's just an insane amount of information hitting their systems every single day. We're not talking about big spreadsheets anymore. We're talking about a completely mind-boggling scale. Next up, there's velocity. See, it wasn't enough to just store the data anymore. You had to process it, like right now. With something like 500 million tweets flying around every day, you need systems that can spot trends and update feeds in practically real time. The old way of doing things, batch processing, just couldn't hang. And the last piece of the puzzle is variety. You see, old school databases, they were neat freaks. They loved perfectly structured data that fit into nice, tidy rows and columns. But modern data is messy. It's unstructured text from social media posts. It's semi-structured stuff like XML. It's images, it's videos. This wild diversity just completely shattered the rigid mold of the older systems. So who is the first to really feel this pain? Well, that brings us straight to the pioneers. This is the story of how companies like Google and Amazon had to solve a problem that nobody had ever really faced before at this scale. What's so wild about this is that the problem wasn't some theoretical thing cooks up in a lab. It was happening in real time. For places like Twitter and Facebook, their traditional databases were literally getting crushed by user demand. The systems were failing, and they had no choice but to invent a new way forward. And that new path forward, it meant a total shift in how they thought about getting bigger. The old way was called scaling up. You just keep making your one main server bigger and stronger, like a giant bodybuilder. But that gets crazy expensive, and eventually you just hit a wall. The new way is scaling out. You just add more and more standard, cheap servers to a network. It's like building a huge, coordinated team instead of depending on one single superhero. Okay, but if you're going to scale out with a huge team, you need a whole new way to manage them, right? You need a new toolkit, and that, my friends, is where Hadoop comes in. It was the 1-2 punch for storing and processing data across a massive network of machines. So first, you've got to figure out how to store all this stuff. Enter HDFS. The best way to think about it is like a digital library for a book that's the size of a city. Obviously, you can't put it on one shelf. So HDFS basically rips the book into tiny pieces, makes copies of them for safety, and then scatters them across thousands of different shelves. And its write once, read many philosophy makes it perfect for analyzing that massive book, but not so great for editing it. And the way it organizes all this, it's just brilliant, really. You have this master controller, the name node, which is basically the head librarian. It doesn't hold any of the actual data itself, but it keeps a master index of where every single piece of data is stored. It knows exactly which server, which bookshelf to go to find what it needs. All right, so HDFS has the storage part covered. But how do you actually do anything with all that data spread across, hundreds of machines? Well, that's the job for MapReduce. It's the processing engine that lets the whole team of servers work on one big problem all at the same time. The process itself is actually pretty clever. First, you've got the map phase, a huge job. Like counting every single word in that city-sized book, gets broken down into smaller tasks, like each person on the team counts the words on just one page. Then, after all those results are sorted and grouped, the reduce phase kicks in to bring it all together, summarizing all the little counts into one final grand total. It's massive parallel teamwork. Okay, so now we have this amazing system for distributed storage and processing. But what about the databases themselves? Well, this whole crisis led to something new, the NoSQL database family, a whole new breed of database designed from the ground up for the kind of flexibility and scale that big data requires. And first things first, NoSQL can be a bit misleading. It doesn't really mean no SQL at all. It's more like not only SQL. And it isn't just one thing. It's a whole family of different databases, and each one has its own specialty. You've got simple key value stores, flexible document databases for things like product catalogs, super fast column family stores for analytics, and graph databases, which are absolute masters at understanding connections like in a social network. Let's dig into a really key difference here. With a simple key value store, the database just sees a key, maybe a user ID, and a value that's basically a black box. The database stores it, but it has no idea what's inside. A document store, on the other hand, is smarter. The value is a structured document, like a JSON file with user details. That means the database can actually look inside and run a query for, say, all users who live in New York. Now here's another idea that totally changed the game: how the data is actually stored. A traditional database is kind of like a filing cabinet, where each folder represents one person, and inside that folder are all their details: ID, name, email, city. To find everyone's email, you have to open every single folder. But a column-centric database is like having separate drawers just for IDs, another for names, and another for emails. So if you only need the emails, you just open that one drawer. It's insanely efficient for certain kinds of analysis. And this column model gets even more organized. You can actually group related columns together. For example, you could put street, city, and zip code all into a single address supercolumn. It's all about keeping related data packaged together for super fast access. All right, so we've got all these new specialized tools, and we've still got our trusty traditional databases. So, what now? Well, that brings us to how modern systems have learned to get the best of all worlds. This leads us to a really important modern idea called polyglot persistence. And the whole concept is that NoSQL didn't come along to replace relational databases. It just gave us a much bigger toolbox. A single big application today might use a traditional database for its financial transactions, a document database for its product catalog, and a graph database for social connections. It's all about using the absolute best tool for each specific job. Okay, let's wrap this all up by looking at the bigger picture. Why does any of this stuff matter to you and me, not just the data engineers at some giant tech company? So, while volume, velocity, and variety were the things that defined the problem of big data, the solutions taught us some lessons that apply to, well, everything. Think about 3 more V's. Veracity: how much can you trust your data? Value: can you actually turn that data into something useful? And visualization: the critical need to present information in a way we humans can actually understand. These aren't just big data goals, these are goals for any modern data system. And really, the big takeaway here is this: these incredibly powerful tools aren't just tucked away in some remote data center anymore. They are literally right here, in your pocket, silently powering the apps you use every single day. Which kind of leaves us with a final thought. How many different types of databases, relational, key value, document, maybe even graph, did you interact with today just by using your phone?